Hello friends, welcome to Truth of Physics. Today I will discuss a very interesting concept of quantum mechanics, that is the Schrodinger picture and Heisenberg picture. What is these two pictures of quantum dynamics basically? I will discuss in this video, and not only that, after that I will discuss what is the Heisenberg equation of motion, okay, in quantum mechanics, like we do in classical mechanics, okay, the equation of motion in Lagrangian and Hamiltonian dynamics, like dA over dt. Okay, this becomes what in classical mechanics the commutation of A and the Hamiltonian plus the del A over del t, and in quantum mechanics these things becomes this is the operator over dt is equals to 1 by I h cut A h plus del A over del t. So this thing is called the Heisenberg equation of motion, that I am going to discuss in today's video. Okay, how this thing comes and all the detailed concepts. So uh, I would strongly suggest you to go through the previous videos of this playlist, the quantum mechanics playlist, that I will give the link in the description box of that playlist. There you should watch the previous videos of the basic and fundamental concept of quantum mechanics, because like e to the power the time evolution operator e to the power minus I h t over h cut, how these things come I have detailedly discussed in a video. So this operator is the time evolution operator. When it acts on a state gate, it gives some another state gate, which is nothing but a time evoluted state gate, or the state gate of the same system but after some time t. This is at time t equals to 0, suppose. So this, the effect of this operator is what this is affecting the state gate, right? So here the operation is changing the state gate, right? So this type of operations, or this type of picture where the state gate is changing, is called the Schrodinger picture, and there is another picture where the state gates will not be changed. The operator itself will change, and that will act on the same state gate and give the same result. Okay, these two things give the same result, the outcome will be same. That how these things come, let us discuss step by step. Okay, now if you have watched the video of my unitary operator, okay, what is unitary operator? There I have discussed that unitary operator, in case of unitary operators, the state gates, suppose alpha is a state gate, it can be represented in two representations, means two base gates, in terms of two base gates. So there I have discussed that any state gate will not, the state gate itself will not change in the two representations, but the terms or the expansion coefficients will be different in the two representations. Okay, two in terms of two base gates. But any operator, suppose we have x, there I have discussed that if this is in the old base gates, in terms of the old base gates, any operator means of what, a matrix, right? So any matrix can be represented by in terms of base gates. Okay, like this operator can be expressed as like this, a dash, this, then this, then this, and this. This is the representation of any operator, okay, or any matrix in quantum mechanics. Now this operator in the unitary transformation, if I represent this operator in the new base gate, suppose it is represented in the new base gate and this is the old base gate, so the relation between the new and the old will be like this. This is the new, x dash will be u dagger unitary matrix. What will be that unitary matrix? I have discussed in that video. Then x and u, this will be the form. So that what is happening here, basically the operator is itself changing, but the state gates are not changing. This picture is called the Heisenberg picture, and the Schrodinger picture is what the thing that I have discussed here, this is what, this is a kind of unitary operator. Okay, now this unitary operator is acting on any state gate alpha Okay, and this is what the after some time. Initially a state cut was this, and after some time it will become this. So operation of this operator on this will give us some another state cut, that is after some time what will be the state cut of the system. So here in this picture the operator u is not changing, but the state cut itself is changing with time. This type of picture is called the Schrodinger picture. So you can understand that these two things, this and this, these two things, they are involved the unitary operations, right? But there are two kind of scenarios, there are two kind of pictures, Schrodinger and Heisenberg picture. uh, if we want to represent a inner product, like we have two gates, okay, like this, then the inner product will be what, like this u dagger and u and alpha. Then what it becomes, this is always 1 because unitary operators like this, u and u dagger, this will always be 1, is equals to u dagger u. So this is equals to 1. So the inner product of a state bra and a state crate will remain unchanged always. Okay, so this thing, what will be this thing? If we have some operator and we want to find this thing, what will become? We'll get something like this. Using this picture, I can write that after some time alpha becomes what? Alpha becomes the Schrodinger picture, alpha becomes this, and what will become this? This will become this, right? Sorry, any bra should be like this. When we want to operate any operator on any bra, then we have to operate it from right to left like this. Okay, so it will be dagger, so it will become b and then u dagger x u and alpha, right? This. Now I can write, yeah, u dagger this, okay, and then this, and then u alpha this. So this is equivalent to writing like this, beta u dagger x and u and then alpha. Now you can see this is what, this is the picture of Heisenberg. This is the Heisenberg picture, right? Heisenberg, where the operator x is changing to this thing. But this is what, this is the Schrodinger picture, where the state gates itself are changing but the operators remain same. So these two pictures, you can see that these two things are mathematically equivalent, mathematically just equal, but there are two types of picture in itself, right? Schrodinger and Heisenberg picture. The operator, so if we have a operator a, okay, then in Heisenberg picture I am denoting with this h. In Heisenberg picture, after some time, what will become this? This will become just u dagger t a and then u. This a is what? More specifically, this a is this h and at t equals to 0, okay, and then u, right, ut. So this will happen, but at t equals to 0, you can easily understand that both ah and as means the operator in the Schrodinger picture, right? In at a equals to 0, both will just be equal, right, coincide. So this is what, this I can write u dagger t and then as and then u of t. Now if we talk about state gate, then at t equals to 0, both state gate will converge, both state gate will coincide, right? that means mathematically alpha at t equal to 0, okay, alpha at t equal to 0 uh, at Heisenberg picture will be just equals to alpha at t equals to 0 in the Schrodinger picture at t equals to 0. But after some time, what happens after some time at t, suppose this becomes the state cut after some time, so this will be equals to some unitary operator into alpha at this is at Schrodinger picture at uh, alpha at t equals to 0, right, and at t equals to 0 both are same, so I can write u and alpha 0, both I can write Heisenberg or Schrodinger, right. So this is the relation like this. Now we'll discuss any operators expectation value is same or not in both the representations, both the two pictures, Schrodinger and Heisenberg picture. So this is what this is, I am denoting the a operators expectation value in Schrodinger picture, and after some time, okay, this is at time t, after some time, and t not equals to 0, and after some time, what it becomes like this is in Schrodinger, okay, Schrodinger picture, it can be written like this is Schrodinger, and then alpha at t. So how can we write this, like in as it is as we know, this becomes what, u into alpha at t equal to 0, right, in Schrodinger picture. So this I can write alpha comma t, okay, alpha comma t equal to 0 or alpha comma 0, and then u dagger for the bra vector, then as, and then u this thing, u and then a alpha and then 0, this thing, right. Now at t equals to 0 both the statements are same, right, I have discussed here. So at t equals to 0 I can write this as s or h both, okay, but okay, this is s, okay, this is s. Now what it becomes, alpha 0. Now this thing you might recall, what is this is ah, right, I have discussed previously, this is this thing. So this becomes ah, take that these two things are just same, right. This is the expectation value in expectation value of a operator in what, in Heisenberg picture. So both the pictures are just equivalent. Now we'll discuss what will be the what is the Heisenberg equation of motion, okay. So for that we have to use the relation ah is equals to u dagger and then a s and then u. Just use this relation and just differentiate with respect to t. Then what happens, we'll get like this. This is the second part of this video. DAH over dt is equals to, now let us assume that this a is, okay, this is not explicitly depending on time, okay, let us assume for simplicity. Then what it becomes, you have to first make the derivative of this, like del u dagger del t, keeping these two things constant, then u dagger a is, just keep these two things constant, and then derivative of this thing, and then the third term will not be there because we have assumed this thing, so the third term will be 0. Now what happens, now I think you all know that for unitary operator or for time evolution operator e to the power minus I h t over h cut, this is what a unitary operator. So for unitary operator we can use the Schrodinger equation, okay. So what will be the form, we all know the Schrodinger equation is like this, I h cut del u over del t will be equals to h u, right, sorry, h u. Then h is what, the Hamiltonian operator, and it is itself a Hermitian. It is Hermitian operator. That means that uh, if you want to take its dagger, then what it becomes, minus I h cut del over del t of u dagger and its dagger means h, and u its dagger means u dagger, and then h dagger, and as h is Hermitian, so it becomes h just. So minus I h cut del u dagger over del t, it becomes like this. So if you take this in this side, so it will become minus 1 over I h cut u dagger and h. This is del u dagger over del t. So just put this thing here, you will get minus 1 over I h cut and then u dagger and h. Now we know that u dagger and u is equals to 1, so just put this thing unity here, u dagger and then u, okay, or it is also equals to u and u dagger, so I can write the inverse or the this thing like this, right. Now this is equals to 1. Now the left things like as. So why I'm doing this, because you understand that this is what ah, right. So it becomes minus 1 bar I h cut u dagger and then h, okay, just I'm writing this first, then I will write this, okay. So and here it will become del u over del t means 1 bar I h cross, so 1 over I h cross, and u dagger and as is as it is here. Why I'm doing this, you will understand after some time. I can write this identity here, this is identity, and then the things hu. So this is h and u, okay. Now what it becomes, so as I mentioned that this becomes now what this becomes ah, right. This thing becomes ah. Similarly this thing becomes ah. So what is this, u dagger h u, and then this is in bracket suppose, and ah plus and 1 by I h cross is, okay, and then plus 1 over I h cross, and then this becomes ah, and then u dagger h and u. So what is this, 1 over I h cross, the commutation of a h and u dagger h u, right, this thing. Now what will be the h in the Heisenberg picture? In Heisenberg picture, the h in Heisenberg picture will be something like this in Schrodinger picture and u. Now the concept of h, okay, was originally introduced in the Schrodinger picture, right, uh, right, when we discuss the time evolution operator in that cases. So that's why for simplicity I can write this thing to be just h, okay, for simplicity. So u dagger h and u is just this, two things are equal, okay. So that means that the h here is this, okay. So this total thing becomes the h, right, means 1 over I h cross and then a h and then h h. So this is what, and this is dA over dt, right. This is dAh over dt. So this is dAh over dt, it becomes 1 over IH cross and then AH and H. So this is all, this is known as the Heisenberg equation of motion, as I have discussed before, and as we have assumed that A is del A is over del T is equals to 0, so there is no additional term, otherwise there will be an additional term del A over del T at Heisenberg picture, okay. This term will be there if you consider this. So I hope that you have understood the concepts of what is Heisenberg equation of motion and uh, all the details like what is Schrodinger and Heisenberg picture, what it actually is. So share this video with your friends and take care of yourself. Thanks for watching.